Hello everyone. In this video, let us see about uniform distribution, which is a type of continuous probability distribution. So, uniform distribution, it is also known as rectangular distribution. Okay. So, here we'll be using the word PDF. Rectangular distribution in the sense a certain interval will be given. In that certain interval, a constant value will be taken as its probability throughout. And note that this is called as a rectangular distribution because of its diagram. So if we take this as our f of x and this as our x and some interval a b is given, some constant value should be there, and for instance we are going to take that constant value as b minus a, because b minus a will be positive. So this should be the same throughout this interval. So if we draw that one, we'll be getting in the shape of rectangular type. So this is called as also called as rectangular distribution. So now we are going to see the definition of uniform distribution. A random variable x is said to follow a continuous uniform or rectangular distribution over an interval a comma b if its PDF is given by 1 by b minus a for a less than x less than b and 0 otherwise. So already I have given the diagram for this rectangular distribution. It is f of x, we can write it as y, this should be our x, and if we take a b either closely or openly, this value should be equal to 1 by b minus a. So now let us find the MGF of uniform distribution. So it is same, mx of t is expected value of e power tx. We are going to use integral, that is integral minus infinity to infinity e power tx f of x dx. So we are going to restrict the limit from a to b. F of x value is 1 by b minus a. Since this 1 by b minus a is a constant, we can take this constant outside our integral. So it will be integral a to b e power tx. E power tx, if we integrate it, we will get the value e power tx by t. And after substitution of this, we will be getting e power bt minus e power at divided by b minus a into t. So this is the MGF. So note that for this distribution, we cannot derive mean and variance from this MGF, because there is a term t both in numerator and denominator. So even after differentiation, if we substitute 0 in the place of t, we will be getting 0 in both numerator and denominator. That is nothing but a 0 by 0 form, which is indeterminate. So instead of finding the mean and variance using MGF, here we are going to find mean and variance using a normal definition itself. So e of x is nothing but integral x f of x dx. So integral a to b x 1 by b minus a into dx. We can take this 1 by b minus a outside. So it will be 1 by b minus a into integral a to b x dx. So x integral value is x squared by 2. If we substitute it, we will be getting b square minus a square. B square minus a square can be written as b minus a into b plus a. B minus a will get cancelled. So our answer will be b plus a by 2. That's our mean value. Variance in similar manner we have to find. It is integral minus infinity to infinity x square f of x dx. Restricting the limit, will get integral a to b. F of x is 1 by b minus a. We can take it outside the integral. If we integrate x square, we will be getting x cube by 3. So and after substituting the limit, we will be getting b cube minus a cube by 3. B cube minus a cube, it can be written as b minus a into b square plus ab plus a square. This b minus a will get cancelled. So this will be b square plus ab plus a square divided by 3. Now variance formula is e of x square minus e of x the whole square. So we are going to do the same thing, squaring on both sides and taking LCM. After some simplifications, we can write this as b minus a the whole square divided by 12. That's what the variance of our uniform distribution. Thank you.